Hello everyone, this is Philipp Jonas for Kalamazoo Valley Community College. And today we're going to discuss money growth and inflation. So the focus of today's lecture is that we're going to learn how the Federal Reserve controls the supply of money in order to keep the value of money stable. That means we have to start talking about what we mean by the value of money. With most other products, we think of their value in terms of their money price. So let's say we've got a basket of goods, and these have a price index, such as the consumer price index or the GDP deflator. Then one way to think about the value of money is to look at the reciprocal of that number. In other words, we're thinking of money's value in terms of its purchasing power. Let me give a simple example. Let's say our entire economy consists of nothing but candy bars. So our basket contains one candy bar. And if this candy bar currently has a price of $2, then let's take the reciprocal of that number, 1 over 2. The value of each $1 would be half of a candy bar. So now let's have a look at what happens when the price of this candy bar rises. So let's say it goes to $3 per candy bar. At this point, the reciprocal falls to 1/3, and the value of each dollar has fallen to just 1/3 of one candy bar. This general phenomenon illustrates that there are two ways you can think about inflation. Perspective number one, it's rising prices. The candy bar goes from $2 to $3. Or perspective number two, it's money losing value, going from 1/2 of a candy bar down to 1/3 of a candy bar. We're going to focus on that second perspective now, as we're going to have a look at the value of money in a simple supply and demand model. That will be our first model of monetary policy today. So, supply and demand. This isn't the first supply and demand model we're seeing, but we don't often think of money as another product. Let's define those supply and demand curves first. Money supply. We've already learned that the money supply in our economy is set by an interaction of the monetary base or reserves that the Federal Reserve creates, the banking system making loans, and consumers in our economy interacting with that banking system. But we want to simplify that down. So for the purposes of this model, let's just assume that the Federal Reserve has this entire process under control and can set the money supply successfully to whatever number they want. Second component, money demand. Now, that's a bit of a strange concept when you first hear it. How much money do you demand? Don't you want as much money as possible? That's not quite what we mean. We don't mean how wealthy do you want to be. Instead, think of all the wealth you have as a pie chart, so to speak. Especially as you accumulate more wealth during your career, you're not going to want to hold all of that in forms that we call money, such as cash or checking accounts. You'll want to hold much wealth in the form of stocks and bonds and other stores of value that carry a higher rate of return. Money demand refers to, out of all that wealth, how much of it do you want to hold in the form of money? And there are many reasons why that money demand is going to vary, but today we're going to focus on one of the biggest, the price level in our economy. The reason you want any of your wealth in the form of money is because money is that special asset that you can use as a medium of exchange to buy goods and services. This is also sometimes referred to as money being liquid. So how many units of money you need to buy the items you want to buy depends on the price level of these items. As a simple example of this, think of living in a country other than the United States. For example, in Japan, the local currency is called the yen. And very roughly speaking, $1 has the same value as about 100 yen. We'll discuss in a future chapter what that's all about. So if you think about how much money you want to hold in Japan, how much cash in your wallet, for example, if you're going out for the night, it's not going to be the same amount of units of money as you would hold here in the United States, because each of them doesn't go as far. In fact, I would suspect that you would want to hold almost exactly 100 times as many units of money in your wallet. Now, of course, the price level is not the only thing that regulates the quantity demanded of money. For example, your income level is going to have an impact because it determines how much you want to buy in the first place. Or interest rates. When interest rates are very high, you'll try to make do with less money so that you can have more of your wealth in those bonds paying a very high rate of return. But today, we're going to focus on the price level. So let's put together the supply and demand of money now to form our money supply and demand diagram. Before I put the curves themselves up, a word about the axes. In general, in a supply and demand model, we put the amount of the item being modeled on the x-axis. So in our case here, that would be the quantity of money in our economy. And we learned that there are different ways to measure that. M1, M2, we won't focus on that distinction too much. But now have a look at the vertical axis. So on the vertical axis, we're tracking the value of the item we're modeling, the value of money in this case, which, as we've already learned, is the reciprocal of a price level. It's not perfectly natural to think of reciprocals. So over here on the right-hand side, I have some training wheels for you. For each value of money, I have the corresponding price level in our economy. For example, if the value of money is 1/2, that's equivalent to saying that the price level is 2. Or in yet other words, notice what happens as we're traveling up on the y-axis. The higher the value of money is, the lower the price level is. They move inversely to one another. So with the axes out of the way, let's introduce our supply and demand curves. First, the supply curve. This one reflects the actions of the Federal Reserve. They control the money supply. Absolutely. That's why we have a supply curve here that has a vertical shape. The Federal Reserve can decide how much money should exist, $1,000 in this example, and keep the money supply steady at that number. If you've already taken Macroeconomics, you will recognize this as a perfectly inelastic supply curve. Number 2, we have our new concept of money demand. At first blush, a standard downward sloping demand curve. Let me remind you one more time what this represents. One of the factors that controls the quantity of money demanded is the value of money. When money has a high value, like here towards the top of the y-axis, you can hold relatively few units of money to purchase the items you want to purchase. But should the value of money fall, which is equivalent to saying, should the price level rise, you need to hold more units of money to conduct your purchases, hence the downward slope. Putting the supply curve and the demand curve together, we of course arrive at our usual equilibrium of a supply and demand model. In this case, we can see that the supply and demand of money regulate the value of money, which is equivalent to saying that they regulate the price level. This is the money supply and demand diagram. Of course, where supply and demand really becomes interesting is when we ask questions about shifts in these curves. Let me give you one such example. Let's say in this world, the Federal Reserve chairperson wakes up tomorrow and decides to double how much money is in existence. Let us use the diagram to predict the impact of that on the value of money. We'll follow our standard 3-step process. Step number 1. Which curve is affected? Well, the Federal Reserve is doubling how much money exists. The actions of the Federal Reserve are represented by the supply curve. Step number 2. in which direction do we need to shift this curve? They are doubling the money supply. That's an increase from 1,000 to 2,000. Step number 3, let's go ahead and have a look at what that does to the equilibrium. We can see as the supply of money has increased, the value of money has fallen. That's equivalent to saying that the price level has increased. In fact, you may notice that as the quantity of money has increased from 1,000 to 2,000, the price level has exactly doubled in this example, or the value of money being cut in half. That was not a coincidence. We will learn later on today why the quantity of money and the price level are proportionally related to one another. This supply and demand diagram is a first introduction to how monetary policy works. But we're going to have a second look at this mathematical relationship today using an algebraic model, a very famous one, a very useful one. But before we get to that, there's a lot of groundwork we have to cover. Let's return all the way to the beginning of this course. You may remember, you hopefully remember, that we learned about variables in our course that are called real versus nominal. Let me give you some examples. Nominal variables we've learned included nominal GDP, the nominal interest rate, and a new one for today, nominal wages. Now, in the past I've said that nominal variables are not corrected for inflation. And that's correct. But let me give you a more specific definition now. What makes a variable nominal in economics is that it's measured in units of money. So nominal GDP is the amount of production in our economy measured in terms of the units of money used to purchase them. Nominal interest rates tell you the rate at which the number of dollars in your bank account are increasing. And a nominal wage is a wage expressed in terms of how many units of money you get per hour worked. Let's contrast that with real variables, which up until now I've said are corrected for inflation. Again, that's correct, but let's get more specific. We refer to a variable as real in economics if it changes because there's a change in physical units in our economy as opposed to monetary units. Looking at the analog pieces for my 3 nominal examples, real GDP. It might have a dollar sign next to it, but it only changes when the output of our economy changes, the number of physical units produced. Real interest rates measure how much the purchasing power of a debt or deposit are growing. And the real wage, that's what you are paid per hour in terms of what you can buy with that wage. This distinction between nominal and real variables will be central to our understanding of the long-term impact of money growth on the rate of inflation. So let's start out with some examples. Let's say we're looking at an economy that only contains 2 products. Number 1, compact discs. I hope you still know what those mean. They were shiny discs that music came on. $15 is the price of each of those in our economy. Good number 2, pepperoni pizza. $10 each. These 2 numbers, 15 and 10, I would refer to as nominal numbers because they measure what you have to pay for those products in terms of units of money. But that's not the only way in which you can think about a price. What if I asked you, what's more valuable in this economy? A CD or a pizza? And you'd be able to tell me that the CD has higher value. In fact, how much higher? Each CD is worth 1.5 pizzas. This perspective on a price, how much one product is worth in terms of another product, is called a relative price. And that would be a real perspective on prices. Let me show you the math. How do we figure out what a CD is worth in pizzas? Division. Take the price of the CD divided by the price of the pizza. So we divide $15 by $10. You might notice that the monetary units are going to end up canceling here. And the result, 1.5, is measured in physical units, pizzas per CD. That makes the number 1.5 the only real number on this page. Let's try this again, this time around with our new variable, wages. How do we express wages in physical units? It's the same idea. Let's say we have an economy where workers are paid $15 per hour. That's a nominal number, monetary units. Furthermore, let's say this economy only contains $5 stores. Stores where everything you could buy costs $5. There's nothing else. So what if I wanted to express how many things workers in this economy can buy for every hour they work? By constructing a relative price, of course. Take the $15 per hour nominal wage, divide by the $5 per unit of output price index. The result, the number 3, is a real figure. Workers can buy 3 items for every 1 hour that they work. This distinction, real versus nominal, it's been around in economics for a long time, and it has a very fancy name, the Classical Dichotomy. Let me break apart for you what that means. A dichotomy is a situation where you take a set of variables and strictly divide them into 2 categories. Every one of them has to go into one or the other. So that's what we're doing here with our numbers, putting them into the nominal or the real bucket. We refer to this dichotomy as classical in economics because it was around in economics before the 19th century. It's a little bit like physics, for example. We might refer to physics of the Newtonian time period as classical physics. A great set of rules, the math is a little easier, even though we know that in this day and age there are certain extreme situations where the classical math is actually wrong. The same holds true in economics. The math I show you now is nice and easy, and it's great at describing the very long run of our economy. Later on, we're going to discuss in a future lecture how it breaks down during, for example, economic crises such as depressions. So the classical dichotomy. Let's distinguish between the nominal and the real. There's a really nice and easy rule in classical economics about how monetary policy works. In classical economics, money is neutral. Another big term. What that means is, when we change how much money exists, it can change nominal variables, but it cannot change real variables. We'll assume this to be true for the moment, even though in a future lecture, I'll show you situations where this breaks. So let's go back to our pizza and CD economy to give you an example of this phenomenon. Looking at the numbers on our screen here, 15, 10, and 1.5, first let's apply the classical dichotomy. 15 and 10 are nominal and measured in monetary units. 1.5 is real. We started today's lecture with a supply and demand model that predicted what happens if we double the money supply in an economy. The price level in that economy doubled. So in other words, if we did that here, if we doubled the money supply and then the nominal prices double, we would expect a CD to now cost $30 and a pizza $20. The nominal variables were affected by the money supply change. But what about the real variable? Price of a CD divided by a price of a pizza. still 1.5. That's monetary neutrality. If you change the money supply, nominal variables can change, real variables cannot. Using this idea of classical economics and a new variable I'll introduce to you, we can put together an algebraic model of the long-term impact of monetary policy. Let me introduce that new variable to you. It's called the velocity of money. The velocity of money is a measure of how often the average dollar in our economy changes hands. So imagine you buy a loaf of bread, maybe pay $2 bills for it. When you've spent those $2 bills, they don't disappear. They might become the wage of that cashier who then spends them somewhere else. Velocity is the count of how many times are those dollars going to be spent in the span of 1 year. And it turns out you can calculate this for an entire economy. There's two variables you need. Number one, nominal GDP, our measure of the total spending in the economy. We've encountered nominal GDP before, but now I have to get much more specific. Nominal GDP is a nominal variable. It's right there in the name. But when we write it algebraically, we write it as P times Y. That's because of the classical dichotomy. We want to keep nominal and real variables strictly separate. And even though nominal GDP as a whole is a nominal variable, if we zoom in, so to speak, it has both a nominal and a real component. Nominal GDP is all the monetary units that are spent on the items that are produced in our economy. That production, that's a real number. That's real GDP. That's physical units that our economy produced. It becomes nominal when we multiply this physical production by the prices paid for the items. So as an economist, we write nominal GDP as P times Y, because zooming in on it, this nominal variable has a real and a nominal component. The second thing we have to know about our economy is how many dollars it contains to begin with, the money supply, using measures such as M1 and M2. If we know the number of dollars spent in totality and how many dollars supported that spending, we can average it out and calculate, on average, how many times was each dollar spent. That is called the velocity of money, abbreviated V. Or in other words, we're going to take nominal GDP, P times Y, and divide by M, our measure of the money supply. Let's do an example of this. So let's move that formula to the top of the page, and let me tell you about an economy. This economy contains just one product, pizza. Let's say it produced a total of 3,000 pizzas. That's a real number. It's measured in pizzas. If I wanted to compute the nominal GDP of this economy, I would need to know the price level of these pizzas. Let's say that's $10 per pizza, a nominal number. Nominal GDP is then quantity of pizzas times price level, $30,000, a nominal number. To calculate velocity, I divide by the money supply of our economy. Let's say it contains 10,000 units of money. If there was $30,000 worth of spending in an economy that contained 10,000 units of money, that means each unit of money must have been spent on average 3 times. On average. Some units of money will just have sat in a savings account all year long, velocity of 0. Some will have been spent many, many times. But velocity is an average concept. Now, velocity of money, it seems a bit abstract at first, but it turns out that it's very useful for understanding monetary policy if it doesn't change very much over time. So let's have a look at that. Here is our economy from 1960 till 2020. In blue, we have the units of money. In green, nominal GDP. So over this time period, there have been tremendous increases in both numbers. Our economy has grown, both in real terms and because of inflation. But when we divide nominal GDP by the money supply and get the red line, velocity, we find that it has changed very little comparatively speaking. It has changed some. You can see that the green and the blue lines diverge. But over the long haul, it's remarkably steady how many times a dollar has been spent in 1960 versus 2020. Because of this, a good long-run perspective on the effect of monetary policy is the quantity theory of money, which is built on this formula for velocity. Now, this formula for velocity, very standard formula, but very often in economics we rearrange it slightly before we use it because it's got that fraction in it, and fractions are tough to deal with. So let me multiply both sides of the formula by m in order to arrive at m times v equals p times y. Convince yourself that's still the same formula. But when expressed in this shape, we give it a whole new name. This is called the quantity equation. Okay, that may seem a bit much that we do a rearrangement of one variable and it's got a whole new name now. But this way we can say, let's start with the quantity equation, and every economist will know what you mean. So let's start with the quantity equation, and in just 5 steps, we can get from this equation to the quantity theory of money. Step number 1. Well, it's more of a fact than a step. If the velocity is stable, all the following steps are going to work. Or in other words, this perspective on monetary policy we're about to have, it totally breaks down in time periods where velocity is not stable. For example, let's say our economy goes through a financial crisis and lots of money ends up being locked up in the banks who don't want to lend it out. That's going to change the velocity of money, and it's going to make this theory much less useful. But we're talking about long-run phenomena here. So let's say the velocity of money is stable. Then it becomes simple algebra. If we make monetary policy, that means we're changing M, the money supply. If V is stable and we change M, this is an equation. The right-hand side is going to have to change by the same amount as however much we changed M. If we double M, the right-hand side has to double. If we increase M by 10%, the right-hand side has to increase by 10%. So whatever change there's in the money supply, nominal GDP will change by the same percentage. But now let's zoom in on nominal GDP. Classical dichotomy. Nominal GDP has a nominal component, the price level, and a real component, real GDP. Monetary neutrality, a bedrock of classical economics, says that when we change the money supply, real variables don't respond. Y is not going to change. So we can narrow this down even more. If we change M, Y isn't changed. But what's that leave? P. If we change M, P has to change by the same percentage for the equation to still balance. That is an algebraic perspective on the supply and demand diagram I showed you at the beginning of today. If you double the money supply, like from $1,000 to $2,000 at the beginning, then the response is that the price level also doubles. Or in other words, sometimes currencies collapse because of hyperinflation, very quick increases in the inflation rate. What is the underlying reason? Very big increases in the money supply. And that's the quantity theory of money. We've now learned the long-run impact of monetary policy. It serves to control the price level. Or if you want to think of it in terms of changes, it serves to control the rate of inflation. In real life, it's not as easy to do this as the algebraic equation might suggest, because in real life, velocity might change on you, and so might real GDP. So you have to control the money supply to compensate for those changes and get the change in the price level that you are aiming for. But this fundamental math governs the process. So for the rest of this lecture, let's talk a little bit about the effects of inflation and why targeting a given rate of inflation is so important for a well-functioning monetary system. Let me start with a very specific example. For example, changes in the rate of inflation impact interest rates in our economy. In an earlier lecture, we learned the Fisher equation. You can think of interest rates as having two components: a nominal component, the rate of inflation, and a real component, the interest rate in terms of the purchasing power change of a debt or deposit. If we make monetary policy in classical economics, it changes the inflation rate. But according to classical economics, money is neutral, so it does not change the real interest rate. Put those two thoughts together: monetary policy changes the inflation rate but not the real interest rate. That must mean it will change nominal interest rates. This is referred to as the Fisher effect, after the economist Irving Fisher. Let me show you a graph that illustrates this phenomenon for the United States. Here we have nominal interest rates in red and the inflation rate as measured by the Consumer Price Index in blue for the United States. You can see that periods of high inflation coincided with high interest rates and periods of low inflation with low interest rates. The relationship isn't perfect because the real interest rate in our economy does change, but inflation is a major component of the nominal interest rate. So why else do we care about monetary policy and its effect on inflation? Well, inflation also has a very subtle impact on the wealth of our citizens. Inflation acts as a tax. Let me explain. The Federal Reserve changes the money supply by creating new money. This doesn't change the total wealth in our economy. But whoever first creates new money gets to first spend it and therefore acquire items. If the total number of items in our economy doesn't change, that means somebody else now has fewer items. That's what we call a tax. And it's one of the reasons why in the United States we keep the Federal Reserve very independent of the government, so that politicians aren't tempted to use the creation of money to raise revenue. This revenue, an inflation tax, is sometimes also referred to as seigniorage. Now, in the United States, this tax revenue is very low because we have a very low and stable rate of inflation. But if you see a country with a very high rate of inflation, you should ask yourself, does the central bank have sufficient independence? Or is the government perhaps using inflation as an alternate source of tax revenue? A very poor source of tax revenue, because it's a tax on those who hold money, which means if you have a lot of inflation, people will try to avoid holding money and hold real assets instead to get away from this tax. That can lead to many undesirable behaviors in our economy. In fact, in general, high rates of inflation lead to undesirable economic effects, which is perhaps the biggest reason why we try to keep inflation low, stable, and predictable. Let me run you through the reasons. And let's start out with one that is often referred to as a fallacy, because it isn't one of the main reasons why we care about the effect of inflation. Often one thinks, hey, inflation means prices are increasing. Doesn't that mean it'll erode the real income, what my paycheck can buy? Well, this would be true if inflation didn't also affect your wage. In other words, inflation is a broad phenomenon in our economy where all prices are increasing, including the price of your labor. Or looking at this through the classical economic lens, money is neutral, and money can change the rate of inflation, but not real incomes. Let me give you an example of some data here for the United States. If we look at the average hourly earnings of American workers compared to the change in the consumer price index, we can see that those two track each other very closely. Inflation is one of the biggest reasons why wages increase. Wages have to increase beyond the rate of inflation for them to be a real wage increase, of which we also see some on average over time as productivity increases, as we discussed in an earlier lecture. So what then are the real problems that inflation creates in an economy? Let me run through them, and along the way we'll learn some great old-fashioned terms of economics. Number one, the one that's easiest to understand: shoe leather costs. So, shoe leather. It used to be that the soles of shoes were made of leather, which wears through pretty quickly. So the more you run around, the faster your shoes wear out. Shoe leather cost refers to any situation where we're talking about a cost of running around, as in we're wasting people's time, not literally destroying their shoes. For example, think of how often you go grocery shopping. Maybe once a week, once every 2 weeks. But what if inflation wasn't stable as it is in the United States? What if inflation was so high that if you wait a few days, you have to pay 10% more at the store? In that case, you would probably go shopping multiple times per week, just as soon as you've got extra money to spend. And there are real costs associated with going shopping more often, such as your time or perhaps the gas or bus fare you spend to get to the grocery store. That's shoe leather cost. The higher the rate of inflation, the more people try to avoid holding money, which means they have to engage in more frequent transactions. Somewhat related, changing prices is also not free for businesses. Many businesses incur costs anytime they want to change a price. These are referred to as menu costs, as in a restaurant that has to print new menus. So for example, imagine you mail catalogs to your consumers with prices. Anytime you want to change prices, you have to mail out new catalogs. Or it can be the value of an advertising campaign, where you've tied yourself to a specific price point and now you have to do a new campaign because you want to change prices. Or what if the whole point of your business is that the price is fixed, like a dollar store? Now, with inflation, you have to change how much is in each of your packages. How many plastic forks, for example, will have to be reduced per box. Many businesses incur real cost when they change prices. And the higher the rate of inflation, the more often they have to change prices. But it doesn't just stop there. It's not just this sort of inconvenience. When prices change more often, it makes it harder to keep track of what price is what. And in fact, when prices change more often, they don't all do so at the same speed. Some prices update day by day. The price of gas, real easy to change. Some prices only update once a month. The menu at the restaurant. So the faster this rate of inflation, we see real prices, relative prices, seesawing between the different products in our economy. That's going to lead to misallocations of resources. First of all, in real terms, because the relative prices are changing. Perhaps at the beginning of the month, everybody buys gas. At the end of the month, everybody goes to the restaurant. But also because consumers will start being confused about what's going on. Prices are the yardstick we use to measure value in our economy. If that yardstick changes on you on a day-to-day basis, it's easy to make mistakes. And it gets worse. You know a place where numbers, dollar numbers, are even harder to change than on a restaurant menu? Well, think about laws. The tax code, just to name one example, is full of dollar figures and taxes on them. For example, if you buy a stock and sell it later, you have to pay tax on this gain in the value of the stock. But what is that gain? Is that real income? The value of the stock will also have increased in nominal terms with the rate of inflation. This is just one aspect where our tax code does weird things when the rate of inflation is high. There are also other hard dollar cutoffs whose meaning may be changed after the fact when the value of a dollar changes. And that perhaps gets us to one of the biggest problems of having a country where the rate of inflation is high or unpredictable. And those two can go hand in hand. The higher inflation is, the more it tends to vary as well. We want it low, stable, and predictable. What if it's high and unpredictable? What that means is that any contract in our economy that's written in dollar terms is changed after the fact as the value of those dollars changes. One classic example would be a mortgage. The All-American mortgage, 30-year fixed. You borrow a large sum of money to buy a home, and then for 30 years, every month, you're making the same payment. Should inflation increase beyond what was expected when this mortgage was written, you're paying the same dollars back to your creditor, but those dollars are now worth less than expected. Effectively, wealth has been redistributed from the lender to you, or vice versa. Should inflation unexpectedly fall or even deflation occur, now that fixed monthly payment represents a larger amount of wealth, and your lender is getting paid much more than your deal originally called for. The less inflation can be relied on to be stable and predictable in the economy, the less people are even able to make long-run deals in dollar terms, because nobody can risk the deal being dramatically changed on them after the fact. This was our discussion of money growth and inflation. I will see you in our next lecture.